Hey guys, welcome. And today we got something interesting going on. So in the last episode, we set up the Pi 5 with the Arc Linux, and I got it set up and put a bunch of shit on there, so that way we can actually do what we're gonna do today, which is the most interesting thing I've done with D language yet. So without further ado, we're gonna switch over and well, actually, let me plug in the shit I need to do, and let me do a little bit of setup on my end, so that way we'll be able to do this pretty easily and see what's, and we'll be able to see the actual Pi. I actually have put the Pi in the case now, so that way it's not just strewn about and pain. So just give me a second. There we go. That should be good. Okay, now it's gonna be actually getting ready. Nice. I don't know how well this will look because I'm actually gonna be using my monitor for this. I've got it hooked up into the splitter and it's ready to go, so the splitter should be, yeah, it is receiving the signal. Okay, good. Okay, time to program today. Oh, son of a bitch. And unfortunately, okay, let's go ahead and get everything set up. We're ready. Here we go. Nice. Alright, I've set up like a home directory and shit, but yeah, it doesn't really, I don't really know how to make users or set up any of that shit. I tried it, but I don't know yet how to do that, so that's out of the scope of this episode anyway. All we really need to work on today is actually getting into the directory, so it should be just this path that I'm going to set up, or that I've already determined, actually. Yeah, it should be home. Because I kind of set up the path for it. And then something ARM probably. Oh, I nailed it. Here we go. So if I put in /call, or actually call ASM, I've set up the calculator program that we wrote before, and in fact, let me make it easier for you all to see this while I test it out and shit. Or actually, just you guys can see it a little bit better now, so it's not just tiny little text. Oh, I should make that back tab invisible. And I should also pop out the chat as well. And do a bunch of other shit. Okay. Okay, I'm still not ready. All right, that should go. Is there stat stock? Okay. Well, this is perfect. There we go. That should be much better. Now I can kind of see what's going on, to a degree. All right. So it works the same as the old calculator. It kind of works a little bit different too. So if I put in addition or something like this, it will work anyway. It will work. I'm telling you guys, this will work right now. 1 and 2 gives you 3. apparently that's the operation we did. So, it takes that first string and basically makes a second string called OP. And OP basically makes, well, OP is just the name of the string, but it strips it down that string, lowercases it, and then sets itself to a string length of 1. So all I have to do is enum the output of that. So if you put in addition, obviously it starts with an A. If you put in a capital addition, it will lowercase it before it even goes to that next step. It just does it anywhere. It doesn't even check to do that. It just does it regardless. So it sends it, and then boom. Then we're on to the next step, which is going to be putting in, it will take you to your loop, which loops right in it. It has to loop, I don't know why, but that's how I did it. So it works for me, and works here. And then it calls assembly functions, which are declared way before anything else. Well, actually, no, they're not declared before the imports, but they're declared early on. And so when I open up my super fancy IDE, or which I'm going to set up in a second, I'll be able to... Oh, wrong system. Oops. Tmux, the IDE of all time. And then, yeah. I'll be able to show you all how this, how that works. Hi, lol. Oh, shit. Or it should be just, I know there's controls for this, actually. Control B... Huh? Nah, I didn't do it. Did I do it right? Control B... There we go. Look at me learning the fucking shortcuts. No way I just learned the shortcuts to set this up. I'm gonna try to make it so you all can see what I've set up. The most beautiful of IDEs. There we go. This is amazing, but it's not finished yet. I gotta do a little bit more work. So we're gonna open up the LS. We're gonna... Man, it must be terrible to actually see this, but I'm gonna open up the assembly program, and then we're gonna see what it looks like. So... What is it called? Oh, Nano... My brain is having brain farts right now. ARM.S. Perfect. I've been waiting to goon to Murzinski from Masume. Damn. That's crazy. So here's the assembly program. I don't know what you all think of assembly. Me personally, I think assembly is a plus. So overall, assembly, I'd say, need to zoom in more. But yes, a plus for sure. And then I like how I have the monitor, but I'm still looking at that screen to be like, can they see it, or are they gonna be completely like, make the screen bigger or something? But anyway. The subtraction function, I don't know how to use it yet. It's just there. And to actually assemble assembly, we're going to go ahead and move on over to the other side. Oh. Hurry up and get there. Oh my god. Just do it manually. No, keep it locked. There we go. And so... That's the wrong one. Here we go. We're going to go ahead and make the assembly. So to make the assembly, before I do anything, I'm going to do rm-rf. That's going to allow me to remove the file called arm.o, which is an object. Now if we hit ls, there's no longer an arm.o. Now, if I hit arm, actually... It should be as-o, arm.o, arm.s. That will call the, or that will invoke the assembler, the GNU and assembler to make an object out of arm.s. So I hit enter, ls, and we now have an arm.o object. So now all I have to do is call the GDC compiler. We're going to do call.d and arm.o-o. I think there was another thing you're supposed to add to this, but I don't quite remember what it was. Let me check it. Let me check that I have it right. Using the GDC compiler, compile dlang with assembly. So technically you could take any .o and put it in there. And if you can make something into assembly using an assembler or, well, compiler to get a .o object, you can just put it right in there as a function. I believe. As long as it's formatted correctly. Theoretically, you could take like C++ and shove it in there. I mean, it already has native support for C++, but it's all okay. It's all okay. Pretty sure that's not what I'm looking for. Okay, I don't know what I'm looking for. Maruzensky is a 9 out of 10. Alright, I think this is all I need to do, though. Fish terminal, that's base as hell. Yeah, the whole thing is just done in terminal. Well, the system I also haven't set up a desktop on. Oh, hold on. I know what to do. It's the name. We need to call ASM. That will compile our assembly into our actual dlang. So now if I hit ls, there will be call ASM. And so we've done our first assembly program with dlang on an ARM system, which I had discussed at the beginning of this month was something we were going to do. And so, since I said we were going to do it, I ended up managing to finally do it after we set up everything else. What if this was an aquarium? Oh, this is an aquarium. You just don't realize it. Alright, let's go ahead and actually run call... we'll run call ASM and see if it works. Boom. And it works the same as it did. Now, there's an issue though, is that I don't know what... to do with subtraction, because I don't know how subtraction works. I love that I can just type in whatever I want. Yay-S ASCII aquarium on Arc will give you just that. What is ASCII aquarium? Is it good? Is it something I want? We'll have to do dash yay. Yeah, I could probably do it. It's a terminal-based program that generates an animated aquarium entirely in ASCII art. No way. Oh, yes, please. Alright, so I need to do yay. So yay-s. We'll have to do pacman -s yay. No target found. Pacman Actually, before we start doing shit up in this terminal, let's actually just go down to the bottom one and do it down there. That's where I'm gonna do it anyway. Oh my god. Oh, what the fuck? It's locked on. It's locked onto my mouse. There we go. Alright, and then we're gonna do... What is it? linutils? Ooh. Oh, wait a second. I know what the problem could be. Ah. I should probably enable this so that way I don't have to do it anymore, but... Seems like we have the repos a bit oddly placed, don't you think? In the bottom? I mean, it's not a bad idea. Because the top is the business area, and then we... netctl. Trying to remember. Oh, WLD0 dash should be that. Oh. Hold on. No, that's not the problem. I know exactly what the issue is. Alright, this is now working. I can't see what it's doing, but there. Now we can do pacman -s EA. No target found. Okay, that's cool. What about linutils? Is that a thing on this? Okay. Let me see if it's available on ARM, the specific, is available. Okay. Is architecture independent and requires the Perl and Perl term animation dependencies. Oh, you know, if you're not aware right now, what are you on really? Like, it doesn't even have any repo yet. Watch this. Boom. Check this out. Isn't this the most amazing thing of all time? What do you think? What is your opinion of my setup right now? This is crazy. Where did the repos go? What do you mean, where did the repos go? Like, you mean, oh, like Pac-Man? Like, no, this uses different repositories because it's not a times 86. It uses the arc ARM usually. W setup, but it needs an update. No. Sudo pacman -syu. Alright, oh, okay. I'll close up what I'm doing and then we'll do that. Yeah, okay, that's cool, that's clear. Moving the screen around. Oh. So, this one's good. Nice. All right. Let's see. Packages. I guess we need the, yeah, that should be fine. Yeah, we can do that. It's oh, dash SYYU, not just SYU. Okay, we can do that too. Oh, shit. No worries though, you can do SYY later on. Oh, okay. Architecture ARC64 not supported. Oh, this is system D doing something. Maybe it's making the, yeah, it's making the init CPI or whatever it's called. Basically like putting it into memory. I had to do this a couple times by myself where I like, you go into the mkinit file and then you edit a bunch of shit. Love chaining commands, pipelines, and so on. It's pretty cool how that works, but now I'll probably want to reboot. But I'm not going to do that. I'm going to pacman-syy. You can do system deboot if you want. We have so many init systems with us. AUR. That's something important, I think. What does AUR do? Synchronizing package databases. So that was... Is there anything else I need to do before I reboot? I hope it didn't update the kernel module. Actually, how do I enable netctl? Actually, let's just do that. These package databases are the repos. Oh, okay. AUR is Arc user repository. Got it. Enable netctl. Netctl enable, which will make it run at startup on boot, but that will slow it down. I don't know if I want that. Actually, it won't be fast because there is internet, so... Yay takes stuff straight from the AUR. Got it. So we're missing the AUR, and then that's the problem. We don't have Yay, though, so but that's it. We'll probably be able to get it now, I'm guessing. Alright, perfect. Looks like it worked. Reboot -H. Resize that shit. Hurry! The screen is a flashbang. We need everybody to... Okay, there we go. Oh, my Raspberry Pi. Oh, shit. Did it work? I need to zoom in. I should just add another video capture at this point. Or a scene. Wait, it's different now. Oops. To connect on the terminal. This will prevent you from this network configuration hassle. It should be good though. I'm fine. I think this will be good. See, now that I've set it up, it should just run on the boot, I believe. Once it's booted, it will be good. And then, just to check, should be IP link. So it's up. Alright, let's go ahead and find our way back down to that one directory. Which shouldn't be that hard to do either. It should be what was it again? Oh, projects. We're gonna go there and then we're gonna make a new directory. Or you can try IWCTL that comes prepackaged. You'd be surprised because it's a bit different running ARM. You don't get NetCT or IWCTL. You just get NetCTL. You don't even get IWD basically. That's until you connect to the internet, and then that took me a while to connect to the internet because I was like, well, I can't connect to Ethernet, so I had to connect to Wi-Fi, and I had to figure out how to get the Wi-Fi to work for a while, and turns out you just gotta make some keys, and then boom, IWD shows up after the next boot, and then it's good to go. It took me like 4 hours, and you can watch yesterday's stream if you want to see me set up some absolute bullshit and try to troubleshoot the actual installation. Will be a better way? Nah, I'm completely good, and I don't really need a network manager thing. I think I'll be fine. We don't even need a sudo. We just need a -s yay. See, it's not found because it's an ARM thing. Wonder if there's a different AUR thing for this. Oh shit! I forgot. It's not on my other screen anymore. There we go. Now it will be loading on my other screen. Do I want a Pac-Man or what do I want to do? I want a Pac-Man or something. Why is this open? Close that. Yay on ARM Arch Linux. Is available for Arch Linux on ARM architectures. It is maintained and so it has an ARC64 build. Oh, it's in base devel too? I don't have that installed either. I'm not going to do that. Nah, I'm good on this. This is not something I need to do today. This is a not now project. With PackSeek, you can get Yay, but I don't really think we need that either. That's not the purpose of the system. I will do that on my main system though. Space Christius.com. We're gonna make directory and we're gonna call it project Or no, we'll just call it, I need a good name for it, because I don't actually know what my next project's going to be in ARM. And I do have the, shit ready to go, I think. Documents. Documentation. Should just be... not the programming in D1. Where's the ARM assembly one? There we go. There. Gosh, these bash comments just refuse to get YT in YT chats for some reason. Ah, wait, they get blocked? That's crazy. Oh shit. I'm trying to resize it so it's more visible. Make directory, and then we're gonna do... what is the next project that I'm gonna do? I guess... registers? Register hell? Yeah, we'll call it register hell. And then we'll just play around with registers. Alright. Now let's go ahead and tmux. And you know what, I'm gonna add another scene now. I'm gonna add another scene. I'm gonna add the actual full size, so that way I could just switch between the two. Is that it? That's it right there. That's not it. What the hell? Is it pipe wire? But it's a pipe wire. Unless this crashes it. Oh shit. That should be good enough. I mean, it's good nobody will be able to suggest distro breaking bashes, but it's a pain in the back otherwise. Alright, now time to do the magic trick that I've learned. Oh wait, is it just... no. Boom. I can do it with just the shortcuts now. I'm becoming a tmux master at this time. What do you think of that? tmux master right here? tmux master race, for sure. We're gonna make a new file, and it's gonna be called, we're gonna nano into it. So we're gonna nano the actual, whatchamacallit. Is there a better version of nano? That'd be pretty cool if there was. I am curious, like, what features it would have and shit like that. So if you do tell me, let me know about that. Alright. Nano, and then it should just be as simple as that. Nano, whatever we're gonna call it, right? Call.d. We'll just call it call.d, so it will be easy again. And then we'll get standard.standard.dio. Put a semicolon in there. Neovim, got it. I'll check that out later today. All right, let me switch to scene 1 and zoom it in. Zoom it in real good on that D-lang we're about to program right here. Some of this D-lang we're going to be programming. And so the first thing you do is you will extern C. Well, after you do standard.dio, you need to do extern C, and then whatever your function is going to be called. So in this case, we're going to call it register. So we'll just call, actually we'll call, I don't know, really. I don't know what I want to do with this yet, so we'll just call it my function. Wait, is this Minecraft or something else? What, does it say Minecraft? What does it say? Oh shit. Did I fuck up the stream somehow? Oh god. What if I fucked it up? Could be screwed up. Totally. Let me check. I was streaming Minecraft earlier, and then this is just programming. This is some programming here. My function. Because I do both. I'm trying to remember what I did yesterday, but I didn't really take. Actually, I did take photos of what I did yesterday. I could pull those up right now, actually, so I can reference them, and make it easy on myself. I think that's what I'm gonna do. Did I take pictures? I swear I took pictures. Well, I took pictures of setting it up, I think. No. No, but you usually play Minecraft with insane mods. Ah. Yeah, and today we're writing with insane languages. So it should be my function. So we're just gonna make a basic assembly program just to demonstrate. Not gonna try to expand any knowledge yet, but then in a bit we'll try to work on some new shit. Funny how we have a fetch command for Minecraft servers called minefetch. After installing that, we can type neofetch in chat and it shows us the server specs. I'm pretty sure you can set it up on a Raspberry Pi too. Extern C. So this will be able to call the external function, and then let's see what's next. I don't have pictures there, but do I have them on my phone? Maybe. I probably have them on my phone. It was weird setup yesterday, but I should have some. Yeah, I do. Oh yeah, I've got plenty of them. Plenty of answers to what the program looks like. Alright, so you will call your function. It won't just be extern C. What program is this? Tmux. But we're running Arch Linux on a Raspberry Pi. Int my function, and then you put in the parameters for your function. So if you have my function parameters, could be int a comma int b comma, and then of course now all you have to do is create some kind of create your void main after you do a semicolon. So call the function in some way. So we can do void main, and it doesn't really do anything to pull in anything. It's just the main program. And if we have something we don't want to call a lot of times, we can be like, put a function with a loop and all that. We're gonna hit enter, boom. I like that because it makes it simpler to write. Then tab, we're gonna do, let's make a for loop. So this will deviate from the original program, but we'll create a for loop, which is gonna allow us to do for count. I'll even make this even easier than the original code was. For count, well, int count. For int count equals like, oh, yeah, and we'll do semicolon. And if we were smart, we'd also call the, no, we can't call that there. We'll call it before void main. So we'll call, since it will be in the same scope, it should be safe to do int, and then make an array for 2 numbers, which will allow us to do this loop twice. We can also do a dot length function, or no, dot length parameter, what was it called? Property, that's what it is. Use a dot length property to get our length. However, we could just do int count equals 2 and just get to that. Or we can set the actual thing is until it equals 2. So that means, well, this is not do until, it's a do while. So do while or yeah, it's a. I know exactly what I'm doing. Don't worry, I can explain the words. Yeah. But anyway, how hot is my pie? It's very hot right now. My pie is hot as hell. It's burning. It needs the fan to run more. So int 2, and then we'll put the name. What do we call this? Like data. We'll name it data. Boom. And then we'll have data 1 and data 2. So that will be how it works. We'll have the count. Count will go up each time. So to do that, you need to do it so where until count equals 2 equals 2. And if you should, I don't remember if you make these, I don't think you capitalize variables. I think you just leave them as is. Space that, and then semicolon. Then you do your next thing, which is going to be the actual plus count. So this will basically increment count every time we do the loop. So the for loop is fairly simple. It makes the int, so it creates int count at 0. Of course, all ints are created at 0. Then it will, until count equals 2, we'll do the rest of this. Or actually, hold on. So actually it's an if statement, more so like an if statement than an until kind of thing. So if count does not equal 2, then do this, which is exactly what it's going to do. So then all I need to do is put in another scope. In this scope, the fact that we're trying things on your own is impressive at this point. Any newbie installs Claude and starts vibe coding, mad respect. Well, I already know how to code in D. I've learned a bit of it. I spent months doing it, but thank you. It's always good to hear other people who also hate AI. Bro, I hate AI because it's just like, you know, you could code, you could be so smart, or you could just choose the easy solution and try to do that. But they just don't want to work hard and try to elevate their skills. Because a lot of times AI is wrong. Like, AI was wrong about a lot of the shit we did for the installation process. If you saw yesterday's episode, we used AI to help us out with that shit. And it was wrong a lot of times, and I called it out on that shit. Because I know it's wrong. So, because I knew it was wrong for some of those things. We're going to write ln, and then we're going to do the actual line, and it's going to be like input an integer angrily, exclamation point. Angry face. Input an integer, angry face. I love this. And then we're going to read, I believe it's read ln. It's been a while since I've done read functions. Easy solution, but doesn't seem right solution either. Imagine starting to make an OS of your own and ending up with as sparkling water distributor, Lamau? As a sparkling water distributor? What does that mean, sparkling water distributor? I'm kind of confused. Is that like actually a thing that's happened to somebody where they end up becoming that? Equals read ln. Of course, we'll create data. So data is going to equal data of count is going to equal that. Now, I could be wrong, but this looks about right, so I'm going to say it's probably right. I don't think it might need to have the %s in there, but that's only, we could probably do a readf, or I don't want to do a strip because that's stupid. And that will be the assignment kind of block. So that will repeat the loop. and it will do it for data until, so data count equals 0, and then we need to do it until data count equals 1. So that's a good thing to catch. We should be able to GDC this soon. Claude Code began making a website for a AAA company. Yes, a gaming industry. And there you go. The entire web page turned from selling video games to selling sparkling water. God damn. That's crazy. And so since it checks the count at the end, or the beginning of the next loop, it will basically be like, oh, go to start the next loop, check count. Oh, shit. Control S. So we wrote 11 lines so far. I'm going to make it look a little bit better because I feel like this looks better. To space some shit out so that way you can kind of see it better. That's just C# turning me into a weirdo. I did some C# programming yesterday, and we might check it out today in a third stream. You know, that'd be pretty cool. No, we wouldn't. I don't want to do a third stream, but I might do it just to show off the little bit of development I've done today and some of my C# skills. They call me the C# shooter. I'm so good at... I'm a sharpshooter with C#. Sharp. That's a dad joke. That's terrible. C# shooter. Damn. We're making good progress, though. It's amazing. Oh, yeah. But now we need to actually integrate in our actual my function. So my function would be the name of the function that we're putting in. You could put in multiple functions into your ASM, which we're going to get into in a bit when we set up our ASM code. And then we'll actually do all the wonderful bullshit with this. Arc user sentiment spotted. That's exactly why we say I use Arc, by the way. To show our skills. Yeah, I use Arc, by the way. Bro, I'm writing only in the fucking terminal. I'm using literally a CLI distro. My distro is command line interface right now. I mean, it could be not, but I just like this. This is fun. Okay, let's go ahead and write out the next line. Which I actually am... This is still new to me, so I'm just gonna... So, to actually use the... Oh. So we need to do another int. And it's going to be int c. Which will be the actual output. So when we do that, we could put it in its own scope, maybe, or we could just call the function into it, or call it, make it a function, call it int data or some shit. But we'll call the function. It's gonna be put into a scope. Should I do that? No. The moment you install a window manager and a compositor of your own, this is gonna get... I'm waiting for that day. I don't know. This is not the... This is the development system. This system we're gonna use to develop another system. See, I can't write the ARM assembly on my x86 machine. So the reason we've even done this, which I never explained, was so that way we can actually set up the assembly to make a bootloader in a system of our own to actually to boot the fish box, is what I'm going to call it, which is going to be an Odroid N2L with 4 gigabytes of RAM, LPDDR4 RAM, 6 CPU cores, 2 of which are the GPU, and we're going to make our own OS for that system. It's going to be Fish OS. Well, actually, that already exists. It's going to be amazing. It's going to be the Fish gaming dashboard, and it's going to host Fish Tech natively. It's going to be absolutely spectacular. Besides that, we're also going to work on other projects, which I just need to get a little bit of funding for. It won't take long. I have the plans. Or actually, we need to do int c. We're going to build a supercomputer. No joke. That is actually something I have set aside funds for, and we are going to work on soon. I just need to get, I believe next paycheck I'll be able to afford enough NVMEs for it, so then we'll be good. But actually, I probably should reduce the amount I'm gonna buy. I should probably go down to like. No, we can do it. We can do it. I'm smart enough to secure the funds we need. So that's gonna be int c, which forgot what I was doing in the original code, but actually no, it's c equals my underscore function, and then the function. I wonder why nobody's here. 7.36k of us are missing. Either they are anti-cheat gamers or they genuinely left YT. Yeah, well also it's because it's the most unattractive stream right here is this one. Honestly, people just subscribe to you and then they either forget you exist or they just leave. It's crazy. So then we're gonna put in the actual data 1. No, that's not data 1. Why do I put a space there? Data 1, comma. No, don't do a comma. Actually, yeah, do a comma. Data 2. Maybe I could make my own graphics system using this, where it's like I can write it in ASM to do like a vector function or some shit, and then run it here. I wonder if I could run D on a GPU. I'd probably be very far at that. But that's what I was working on with C#, was running it on a GPU. I also learned a lot about the GPUs and how they work based on that. Now we just need to make my function, and that will be good. And I think I remember exactly how to do it, because ASM isn't that hard for my brain to understand. And it's supposed to return my function when it's called. So this will be an int function, because we an extern C. So up on the extern C, we declare it as the other thing. Call me a schizo, but I think adding arc, by the way, and on the title might work. Good summon for arc elitists. I can do that right now. Give me a second. Alright, let's go ahead and do this. Control S. That's every single line. I like how the screen's like a color tester. Yeah, put an arc, by the way, right up there. There we go. Then I'm gonna have 1,000 people telling me to install Yay and shit. Arc, by the way. I've done it. We've truly done it with this one. Alright, let's go ahead and do something that won't be terribly nauseating for people. But hopefully I'm getting good at this slow movement of this. We're going to go down to there. We're going to set up the other thing. Alright, let's go ahead and ls. We should have call.d. We're going to nano and make my function.v. Or .s. myfunc.s. That's a crazy name. Alright, so now that we have myfunc.s, it's time for us to write some stuff. That's gonna be fun, because it's really fun to write things in GNU if you haven't already told. I think the first thing you do is you... Hold on. I have a photo of what I did yesterday, and I need to reference it. You declare it global, then you do type, and then you align it. So you do a .global directive, then you do your type, which comes afterwards. So your global will be my function. Or, well, actually, it'll be my underscore function since we called it that in the first one. Arc user spotted? Holy shit. No way that actually worked. Yeah, we use Arc, by the way, here. All my systems run Arc, too. Arc's the best. Haven't had any issues with it. So that should be good. And then I need to do, like, 2 spaces to actually align it, but that really doesn't matter. That's only if you want it to look pretty. I kind of want it to look pretty, so I'm going to do that. Yes, I could tell. Everybody here is an Arc user now. We're going to see that 5,000 Arc users show up, and it will be crazy. So we're going to do that. Actually, if you want to see something even more interesting, then I really like to show off, but this is the type of Arc user that is insane, but boom. We need more like these. I hate everybody going to Ubuntu. Yeah, Ubuntu like destroyed my system. I tried Ubuntu and then it just completely failed. Like Ubuntu, I had the most problems with it because then the entire file system became write-only. So far I haven't had that issue, but I've also been pretty good about shutting down my system more often. Yeah. And it's on a Pi 5. It's insane because to actually get it to work, it took so much troubleshooting to get the Pi 5 to work. I feel like it's a big flex for me. It's probably the most insane shit I've done. No, it is. Type. I think this is type. I'll re-ref. Oh, it is a type. So type, we'll call it my function. Technically, I could just reference the documentation I have since it's pretty good. Yay works. I haven't tested much to like get it to install, but I need to get what is it? The devel tools and shit. My function. Can't spell function without the word fun, right? Oh god, hitting them with more dad jokes today, I see. That's what I see right now. And then we'll call it my function, right? Or, oh. Type is function. So type just means my function is now a function. That's what this directive means. Then you do the dot P2 align. I was right, it is P2 align. Oh yeah. P2 align right there, bro. And I've lined everything up perfectly on the top so it looks pretty. I like assembly because it's columns and it looks nice, but also it's super advanced. Now here's the other thing you don't want to forget is this next part. If you forget this, then bad things will happen when you go to try to make it. So you need to do my function colon to create the function, and then that's if you name it my function. But then you can do your actual stuff. Raspberry user mostly go to Alpine Linux for some reason. Yeah, I mean, I think it's partially because it's harder to install Arc on a Pi. It's not that hard if you do it the like actual if you have a Pi 4 and you follow the documentation is pretty good for the Pi. I'll send I'll put a link in the chat because it's pretty good, and it got me pretty far, but it didn't get me all the way to the end of what I needed to do for the Pi 5. The Pi 5 has extra steps which aren't covered there. Let me see. It's like arc Pi ARM Pi 5. Oh wait, Pi 4. I just used the Pi 4/3 or 3 documentation. Here, this will get you where you need to be. Ugh. If you want to try it yourself, that is, or if you can try it yourself. But that's the documentation I used. So my function, then we can add, we can do the, I believe it goes register, and then, the endpoint, and then the other two registers. So if you're adding, if you want to do 1x, well, x, it's x0, x0, but you have to put commas after everything too, so don't forget to do that. x0, and then one more, which is x1. That's going to be adding x1 to x0 and putting the result in x0. Congratulations. It's not actually the ARC wiki, it's the ARC ARM wiki. Actually, it's ARC ARM wiki. I think I'll use ARC when I build my supercomputer cluster of some kind. Well, I definitely know that's what I'm going to do. ARC is just, like, perfect. There's nothing better than it. I feel like everybody should be using ARC, so that's how I feel. And we need to do return. Although, from what I've read, there's potentially RxLB, or something else more advanced than this, that works on multiple different types of architectures, allowing it to be a little bit more portable. But this is not very portable, so we love assembly here. Yes. All right, time to actually go into the assembly phase of assembling this shit. Oh shit! Don't move. Oh, terrible. So if I do ls, should have those two things. The first step, as-o. That's going to create the myfunc.o from myfunc.s. Bro using arc. Bro talks like talks Gentoo. Gentoo? I talk Gentoo? Do I? What's my opinion on? I've never tried it. I haven't tried it. Oh shit. Maybe I have to try Gentoo. Damn. I gotta distro hop to there. Too hard. So then ls. We should now have myfunc.o. If we were to nano in there, it's gonna have our functions. Alright, so now the question is, did we do xturn right? And if so... Alright. What we're going to do now is do... actually, we're gonna invoke GDC. So we're going to invoke GDC. Going to create... Well, no, we're not going to create it. We're going to use the sources, right? So the sources are going to be call.d. And then myfunc.o. There we go. No, don't switch already. It's Richard Stallman's distro. You will have to make everything from scratch, like even the editor. I could probably do that. We could write it all in D. It'd be probably a fun project. They need more D-Ling. Yes, this is the year of the Linux desktop. Every year is. It's like Half-Life 2, or no, Half-Life 3 is about to release next week. Gabe Newell told me that Half-Life 3 is coming out next week, guys. I have insider knowledge. Maybe Discord announced 2026 as the year of the Linux desktop. So, bro, I bet the the amount of Linux users has increased exponentially this year. I bet it's all part of the government's plan to get everybody on Linux. Or not. I think that's a side effect of their plan. All right, time to something. What do I need to do? I need to make a name for it. Come up with a name. Call, or yeah, we'll just do it. Call ASM. Again, just make it simple. Oh, wait. What? Variable name? Did I do using? Did I write using? I'm sorry, did I fuck some shit up? Extern. Hold on. Is that a it's a semicolon. Thought you were joking. They legit have a video on YouTube. What the hell? What do you mean? Oh, wait. Discord did that? Oh. Talking about Discord? I thought you meant like Half-Life 3. I was like, damn, I actually predicted that it's releasing. Is it extern lowercase c? I'm confused. It did. Oh, I think I fucked some shit up. Actually, I'll just check. You know what? It actually probably is. No, it's capital C. Import. Oh, you know what I did wrong? I figured it out, guys. I am so stupid. Somebody forgot to put in their import. Man, I'm losing it sometimes. Control S. Should check out Discord's YT. They actually decided to shift their workflows to Linux. Alright, and then, of course... Oh, Dadat? There's a Dadat in there, somewhere. Data. Variable name expected after type, not... Oh, did I save it? No, I did save it. Very interesting. Absolute Cinema. Something just weird. Datat count. So it's in the loop. What the fuck is datat and why is it in my loop, bro? Ain't no way we got datat in the loop. I think next I need to get Arch Linux for the microwave. And for the fridge. Then let's see. Cannot pass data of type int to parameter int b. Oh, wait. Oh. Hang on a second. Oh, shit. Oh, you know what I fucked up this time? We put in not a 0 and not a 1. I just did human counting instead of D-lane counting. I have homework to do. Keep it up. Alright. Have fun with your homework. Or not. My function is not callable using the argument type int. But that should be perfect. Also, is that Tmux? Yes. I don't even have a desktop environment. I just use the command line. It's awesome. So we have that. Those indexes were out of bounds. We fixed that, but then it's still expecting Is Discord proprietary garbage? Yeah, it is. Fuck Discord, bro. Everybody should be using Matrix right now. Oh, well, I'm gonna get it later. I've been told about it during this stream, so we're gonna do that. I bet, is NeoVim great? I bet it'll be fun. Fun to use. I'll have to learn it, though, but I'm willing to do so. Int my function int a. Is this how you call an extern C? My underscore function int a and int b. Yeah, I think that's how you call it. Wait a second. Oh, another thing. Int C, we can get rid of that. No, use Emacs. Not anymore, they're going to shift to video encoding instead of that Electron BS. That is what, until they do something shitty again. So let's actually fix this. Int C. So this will make it actually even more better, more gooder than what it was before. Instead of declaring it more than one time, we can just do that. And then, I believe... How do we screw it up there, though? So we do import standard IO. Or is it spelled correctly? I mean, it looks like it's spelled correctly to me. Does it have a semicolon afterwards? We'll try building it again, because I don't know what's going on with that. But that should be pretty much all of the errors. Cannot implicitly convert expression. Where are we at? Data count readline /n of type string to int. It needs to be readf. Okay. Well, we'll figure this shit out. Somewhere in here we have it so it's going to call the read line. So the data of count equals, there are so many great editors, Emacs, NeoVim, LazyVim, Ranger, Obsidian. No, the last one is trash. Huh. I guess we'll do readf. We'll do a readf, then we'll do... You have to do this because it strips out any spaces. Then that should be it. What did I do? I screwed some... Oh. Control C to cancel. Oops. Alright, let's do that again. Oh, okay, now it works. I don't know what I did. I guess I did it right. Do a readf and it just works, guys. Call ASM, which will now allow us to assign numbers to it. So if we input an integer, it gives us that. We can be like, 245 0? What the fuck? Oh shit. It only wants us to do it one time. So at the end of it, it pluses count. Oh, hold on, let's go back. Hold on, my bad. I didn't show you guys the other part, but hold on. Let's go back. We have to go back over here anyway. So I'll scroll us over to the other side this time. I'll remember to do it. I was so lost into testing, but so we can read the read function to do that. Until count equals 1. So starts at 0. Let's just do 2. Once it equals 2, then it will be done. And And let me go ahead and move us over to here so we can invoke the compiler. And you all get to see the beautiful compiler invocation. Invoke GDC. Go. Do it. Mwah. /call ASM. 100, or actually 1,278. Input an integer and it just fucking defaults to 0. What? Hold on 5 seconds here. How the hell does it default to 0? It doesn't even get to the end part. It's just like, fuck it. We're done after first try. It yields a result of nothing. I think the problem is in, actually, the code. Oh god, I need to, like, set up some kind of fancy animation system to drag these things for me. Well, let's just get rid of that %s. I think that's part of the issue, because it's doing some weird shit. Doing some weird shit, yes. And it doesn't like readf. It kind of breaks shit anyway. Control S. Control B. If somebody supports an anarch, they become anarchists. We support arc. Are we archists? We are archists here. We are the... It's like the Rust stations, but better. Instead of being rusty, we are the arcations. We're archists, okay? Archists of the highest order. You can tell because when I use fast fetch, it says I'm using a fucking Raspberry Pi. No, enter. Oh, I'm doing it on the wrong system. Oh, shit. I got my keyboards confused. That's good. Son of a... I'm doing this for you guys, by the way. The actual... That sounds so fucking weird, but... I'm moving around the screen for you guys, because I know you all won't be able to see if it's, like, fully zoomed out. Man, these things are worth clipping and uploading as a separate video of their own. Yeah. Like, honestly, you see, the only reason I don't really do that is because I'm too lazy to actually go do it. And, I also don't really... It would take away my time from other projects like this. Like, I wish I could hire somebody to do it, but, I don't know anybody who would do that, so... Plus, I don't know how much I would like to work with people on the internet to do that. Shall we all have these tools called glasses? Oh, okay. Well, yeah, but... You know, if I switched over to this scene, I mean... What... Look at that. How bad is that to watch? I mean... Can't be... I mean, it can't be that bad. Let me actually see it. Oh. Hold on. That's not that bad. Well, I mean, it's kind of delayed, right? 1 hour and 16 minutes ago. 1 hour and 16 minutes ago, we were staring at a fucking... Wojak. Oh, that's not that bad. Yeah, we could do for more of that. I think we can do that. I can see everything. Okay, this is perfect then. Good. If somebody comes along and says they can't see shit, then yeah. Just so you know, I'm using Browsh. Awesome. Actually, if you use full screen, it's probably fine. Let me check full screen out. Oh yeah, full screen, bro. Full screen is damn near immaculate. Damn near immaculate, okay? Full screen will be perfect. The terminal browser. Ooh. Holy shit. That sounds like something I'm gonna have to get on this one. Actually, I don't know if I want to install a web browser. It would use a lot of resources. I'm trying to be a resource maxer and not use all my... Actually, wouldn't that be inverse? Where like resource maxing is like using all of your RAM and having 30 web browsers. So why doesn't this code work? So it does until count does not equal 2, or no, it goes until, if count does not equal 2, it does plus plus count. Count should be incremented on each iteration. And so when you do the readf, it should put that in there. So until it does not equal 2, Borscht takes like, okay. Browse takes like 120 megabytes or something on idle. Oh, very cool. Maybe I will check it out. Very neat. Let's see. Maybe I don't use readf. Maybe I should use readln. Actually, let me just reference some of my code I've written before. I'm sure that actually would be a good idea. Because the code will transfer over regardless of ARM or not. I'm gonna go to my desktop. DTools. And then we're gonna check out functional gaming. I have one that's called functional gaming. We'll check out calc.d. So it reads F. Oh. I am dumb. Congratulations, everybody. I might be stupid. Browse. Browse. We like the browse. I am dumb. Guys, say with me. I am dumb. Actually, does say that with me. Not everybody here is dumb. So it's data. You can just put it in here and it works. It's a readf, not a writef. So, yeah, that would have been nice to have figured out on the first try. Hopefully it works this time. Control us. Control B our way to the other side. We are dumb. Yes, exactly. Oh, yes. Now it's time to /call ASM. 1, 2, 3. Oh, I'd go a step further. I'm a maniac. Same. Alright, let's try it with like 230. Yeah, that number. And then this number. Hell yeah. Now, I'm guessing what's happening is pretty simple. So what's going on is that we have... Hold on. I could make a diagram of how... Well, actually, it's really simple. So, when you do add, right? It's not adding one bit. Okay, it's not doing that. It's taking whatever alignment or whatever the fuck amount of bits. So to get an overflow, I'm guessing we have to go over like 8 digits probably. And I don't know what this will do, but oh shit. Give it a number like that. And then another number like this. Because I'm pretty sure it's only using 8 bits. Oh, holy shit. Maybe it does work. But binary is interesting because you can represent a massive number in it without using much. Well, if only using like 32 bits, you can represent a massive number by just having it go up and up and up. It's really, really cool. I think it's hard to explain, but I have it in my mind how it works. Kind of. It's very interesting. So now, what we can do is learn a new function, new technique, and implement that into my assembly, and then rebuild my assembly file. So what we're going to do is we're going to go up here. We're going to go ahead and ls. We're going to go ahead and rm dash rf, and then we're gonna do call. Actually, let's do call ASM and my func.o, my function.o, and then ls again. Cool. So now we have call.d and my function.s. In fact, you know what's great is that you can technically call C and C++ functions in dlang. Hell, you can even call C# into dlang. And vice versa with C#, you can actually do pinvoke on D language bullshit. So this is an amazing language. Both this and C# have a lot of capabilities that I like. Now that we have done return, I'm going to read into the paper. So I have actually downloaded a kind of a guide on it for the assembly, and it's called Getting Started with ARM Assembly Language. So that's the actual guide. And then chapter 5 covers registers. Most assembly instructions perform an operation on data in memory. For example, we might want to do any number of the following. Increment a number by 1, add two numbers together, subtract one number from another, multiply two numbers together, and then add the result to a third number. All data values must be stored in some kind of computer memory, otherwise the processor would forget all about them. When you think about computer memory, you might think about the hard drive in your laptop or the RAM memory chips as far as the processor is concerned. These all provide long-term storage, but when we look at individual assembly code operations, data must be in a special kind of memory that is part of the processor itself, which is registers. And to continue on, the A64 ISA provides 31 general-purpose registers for this guide. We will say that these registers are called X0 to X30. They each contain 64 bits of data. In fact, A64 assembly code. I would show you all the guide, but I don't want to flashbang you all. And so that's another thing. Because this is literally... The entire thing is... I don't know if I can force dark mode on this. This is very sad. But anyway. In fact... So then... I'll actually just get a link and post this. That way, if you want to mess around with this, you can do that too. If you want to follow along. ARM. Hold on. ARM assembly guide. And it's like one of the first ones that pops up. Alright, ARM assembly, ARM developer suite assembler guide. Where is it at? Documentation. There's a lot of documentation for it too, which I like. It's a PDF. Copy link. Perfect. Here you go. If you all want to follow along, this is the actual documentation. To read more about the general purpose registers, see the C-learn architecture, A64 instruction set, registers in ARX64. Loading data into registers. All data must be in a register before it can insta-read it and came back. Oh, okay. Damn. Must be in a register before ARM assembly instruction can operate on it. if this is the first time we have used the value, then we will probably have to load it into from main memory into a register. The LDR instruction transfers a single value between memory and general purpose registers. For example, the following instruction loads 64 bits from address into a register. So LDR, we're going to mess around with LDR. This will be very cool to see what LDR does. LDR. And we're probably going to have to modify the D-line code to actually launch this thing, to run this thing. But it shouldn't be that hard. It should just be, in fact, getting rid of the for loop and probably just putting in a single readf. Or we could do, yeah, something like that. Probably put in a readf. That will be the actual. We'll create a LDR reader, load register, and then return x0. For example, the following instruction was into register 0. This guy does not use the LDR instruction as often as you might think, because passing data we need from our C program directly into registers. Okay, so then let's go ahead and put in x0, comma, and I want to read more about LDR. So, just so you know, the PDF is expecting you to use Ubuntu. So what? That's not going to stop me. Ubuntu again. Yeah, that's not going to stop me. I need to know register addresses though. So then we need to create a register address for it, I guess. Oh wait. Or loads from an address. Two different ways. Each register can be used as a 64-bit register or a 32-bit register. Oh, hold on. So if you wanted to have a really fast program, I think one way to do it would be to use it as 32-bit registers. So that way you could write like a program that's like, all right, let's say you wanted to do two things simultaneously, right? Theoretically, you could have your data as 32 bits on two different registers and then load it into the thing and then hope the instruction don't flip things up more than set them. I'm just trying to figure out what the addresses are. Actually, I could do that by just probably searching for ARM, ASM, addresses. Confirm you are a human. Alien, are you a human being? Yes, I am. Oh, it does not support absolute addressing, but... oh my god. And it won't take a... So you could have... Whoa, okay, this is pretty cool, actually. It's too bad I can't show it on the screen, but, there's, on electronics that stack, there's a... Actually, I could show it. I could just put it on my other monitor and switch the thing. So, LDR, and it does R1, and then comma equals some address. But, actually, I could just go to ARM developer documentation. Oh, should I put that on our screen? Verify that you're not a bot? Greetings, humanoid. I'm totally a human. We're gonna switch the actual scene. No, not this scene again. Get rid of that. Oh, nobody was expecting this. Load addresses into registers. I actually can't see that. Oh, now I can. This is weird, but I'm using the viewport on OBS to watch the other screen. God damn. Something always has to be on the other screen. I can't see that. I need to zoom in. It is often necessary to load an address into a register in several ways. LDR, RD, label. Ooh. But does the book do that? Does the book have that? Have that feature? Like the book should have that feature. The book should have the feature. You should be able to tell us how to do it. So I want to learn how to use LDR, but how to use for most A64. So this instruction should be load to from. Nobody would have expected a KDE environment, really. What environment would you expect? Like the XCFE one. For example, if you look at the example assembly code calling an assembly function from C code, you can see we do not actually load any data into registers before we start adding them together. This is because when we use the call function, my function from our C code, the C code automatically puts the parameters in x0 and x1 for us. The rules that govern parameter passing are defined by a document called procedure, and for the ARM no environment, straight up hyperlend /neri/i3/sway. I'll have to learn how to do that on one of my next installs. Maybe we can do that together. In fact, we can do the whole original one. The original method of an installation instead of doing arc install next time. Because when I installed on this one, I just used arc install. I was like, next time I'll be ready. I'll be like, alright, time for us to actually cook up on this one. Take 3 days to cook up the arc distro. It's not that hard though. Really isn't. Verify you're not a bot. Verify you're not a bot. Checkmark. Like that. We can also move data around from one register to another to perform different operations. This copies from one register to another. Luckily, you don't have to learn these, just like a regular Pac-Man installation. Oh, okay. In fact, when I used PyOS, I had to install Xorg, which is also... Right, when I used PyOS, I installed Xorg on my own so I could put a screen on there. Technically, we could put a screen on it. On the ArcnPy. ArcnPy, yeah. Program flow, as with many other programming languages. Assembly executes instructions one at a time. Back in my days, cough like an old man, we used to configure Window Manager on our own. Xorg is the base below XFCE, or i3. Alright, so let's see. My function is the label, this is used by our main C program to jump to our function. Instruction, use xlibra plus DRO. We'll look at how to control program flow in a later section, tests, instructions, branching, and loops. But for now, it is enough to know that when reading an assembly code example, you start from the top down, one instruction after another. That's easy peasy. Alright, so ARM A64 assembly provides many different instructions that can perform arithmetic operations. The format of each individual instruction dictates how many operands the instruction takes and what they're used for. So operands are like the three things with the commas. So I mean, we're gonna do math stuff because that's what the guide's covering next. They wanted to bring up that LDR exists, but they didn't want to bring up how to use LDR. And I don't want to learn how to use LDR right now in the middle of the stream. I feel like it's a outside of the stream thing. Then I'll come back and I'll be LDRing all the fucking time. You guys won't even be prepared for my LDR. So we're going to do, so they have add, which the first operand, for example, if I had add again, first operand x0, right? That is basically just saying where it's going to go. That's the destination. And then you're adding, the next one is register 1, and the next one is register 2. So the destination, it can be register 1, and you're adding register 2 to register 1. That's how we're doing it in this case. As we saw earlier, the first operand in most A64 instructions is the destination. So this instruction takes the register x1 and adds it to another, or adds it to the value stored in register x0. Finally, stores the register in x0, overwriting the previous one that was stored in there. Other basic arithmetic operations function the same way, such as the sub instruction to subtract or the mul instruction to multiply. These instructions will be explored more in the examples in this guide. Base instructions, this is a small number of instructions such as move, add, and return. However, there are many more A64 instructions available for use in your programs. A64 base instructions provides a complete list of all available instructions for you to refer to. Okay. Using, actually, I should open that up in a new tab. Yes, thank you. Thank you, thanks. I like that. Using a debugger? What? No, we don't use no debugger. We're developing on the fucking bullshitteroni. Debugging with ARM. Development, no. No GUI, man. We can't program with no GUI. No GUI. Whoa, register values. Well, that's cool. Debugging with GDB on AARC64 Linux. AARC64. Let's investigate how our example program from calling assembly code function from C changes the values. So reading symbols GDB. Okay, we need to get GDB. What? Am I sure about what? GDB A64 out. So we need to use GDB. Load the debugger GDB. John Cena peeping from a hole behind. GDB out 64 A64. Okay. So we can debug shit. It tells us that shit's broken if it's broken. Let's try that out. That's actually cool. GDB. Alright. Pacman dash S GDB. This is so great. Can be done using GCC like always. Yeah, but I'm using GDC. But I want to try out GDB anyway. Like, can we just, if we were going to do direct assembly, we might just use GDB. So then it says to do GDB. Yeah. I'll try GDB from, oh wait, we haven't compiled anything. Never mind. That's, bad. Yeah, we don't need a GDB shit. Well, at least we have it so we can remember that GDB is available for debugging. Wait. This is weird. Okay, never mind. Yeah, let's skip this section. This is stupid. We don't need to debug. I know exactly what I'm doing. We need GCC git and base devel. Since when? Oh wait, now we have branching and loops. Branching and looped instructions are closely related to test flags. Conditional branch instructions check values in test flags and then jump to a certain point if the program based on the result. When we put a conditional branch instruction at the end of a function and then tell the branch instruction to jump to the start of the function until a flag is set, that is, until a condition is met, and we have ourselves a loop. Nice. So, we'll create another function called loop, I think. Wait, what? So how do you do that? Test flags? Oh, there's a whole section here. So then the CMP instruction lets you compare two values. For example, to test that two values are equal, or if a value is less than or greater than a specified number. The CMP instruction compares a value in a register with another number. This other number can either be in another register, or you can use an immediate value, for example. Okay. So we're going to add a function. So what we do to add a function is we'll just do the same shit we have for the other one. .global, and then we're going to do, call it loop. Next, .type. I'm gonna do 2 spaces, 3 spaces, and call it a loop. And then comma function. And of course, I don't think you need to do like any kind of like. No, technically, if I wanted to have it be set to run for like a certain amount of time, so that this is actually pretty interesting. You could do add an increment each time. So add x0, x0, and then x1. Oh wait, well I'm fucking punctuating with what am I lost in the C#, bro? I go to write a sentence out, I always end it in a semicolon now. I'm fucking going insane. Alright, so now we want to return. So what does RET do then? So we do RET. And then do we do CMP? And then we will do, yeah, that's definitely relatable. So we want to compare, this is where we need to do somehow set a register. But here's the thing, I'm thinking, right? So if we have a register set, we want to, when we do that, we don't want it inside the loop. So we need to be able to label something. The second operand is larger than, sets the negative flag in the NZCV. Alright, what is this? We don't always have to test code that flows linearly. Sometimes we want to jump around our code. This is done using instructions. Branch instructions. Test instructions whether a particular condition is met, and set condition flags based on the result in the processor state, P state, and the condition flags referred to as NZCV condition flags. You can then respond to a flag being set that is a condition. So I know what we want to do. I know we don't want to have the part where so we need to declare a value, then we're going to compare those two values, right? So if we have, we could just do and compare it to the number of another value. However, if this is a non-defined loop, so like you can use a hash to declare it as a 5, right? So we could do that. Put in x and then 0, and we declare it to, or we will make it, we'll do hash 64, so it will loop for, compare it with the number 5. There's also, you can compare it to, I hope that works where you can compare it to 64. I mean, I want to do this, we'll call this loop 64, and then make sure all that represents. And then we also need to go down and do a whole bunch of other shit. If you didn't notice, I screwed up a couple things. Need to put in my loop 64 and my P2 align. And then I can do 4. And that should be good. I don't put semicolons anywhere, right? Yes. No semicolon. Alright, so we're going to continue working on this. So now it should loop for 64 times. That should be pretty much all it needs to do. And each time it should return a value. So when you call an int for this, it should be able to do that. But the thing is that just because it compares it does not return a value. So, I mean, we need to actually do that as well. Okay. So there's no like flag that allows you to return to it. So n is negative, z is 0, the result of the operation was 0. Can occur when two types being compared are the same. C is carry, unsigned. Overflow, signed. Example, decrement until equal to. So they do sub, and they'll do something with 1. Subtract 1 each time. Oh, this isn't just incrementing. This is actually doing some weird shit. So we need to actually put in a number. So instead of doing 1, I mean, technically that would mean you could do any number, actually. We'll do that. The value in register 1 will not change, but the value in register... the value in register 1 will be fine. It will change. The register in 2 has the actual value. So when you declare it, it will be int A, int B. Int A is going into register 1, int B is going into register 2. And then that's going to be... yeah, it makes sense, right? Yep. And then I guess return doesn't go inside. I don't understand return yet. Let me search up how return even works. So function return something. Use the return from subroutine by branching to the address in link or specified register. Return does not do anything with x0 at all. Ret is just how you write move PC x30 is the link register. So X30 is the link register where the B branch and link puts a return address. Okay. So does that mean it will work? It means if we put the return in the loop, it doesn't really make a difference. So it just means to move X0 to X30. Basically. So that's cool. Or, depending on the language, I guess it could be different if D-Lang handles it differently. Science. Molecular science. Grok like science. I mean, Grug like science. Grok, bro. Got Grok in my head, bro. It's a caveman AI. Straight up caveman AI. So B.any? What does B.any do? Branch, if not equal, instruction can be used inside a decrementing function, looping and testing. Assembly being assembly? Yeah, assembly's awesome. I like assembly. B.any. This is weird as hell, but this is apparently what B.any is. It allows you to branch if it's not equal to, and then boom. So what does it test? How does it test? How does it test? Test. How does it test? Can be used inside a decrementing function, looping and testing until two numbers are the same. And then boom. Gold. Oh, let's go through line by line. I don't want to go through line by line. Oh wait. My function. Oh shit. Actually, I am dumb because it will return. Will it return? No, it won't. No, that's just to say return to the other one. So after it does the check, you do B.any after your CMP, and that does everything else. B.any, and then we'll do the rest of the functions in there, which is like would have returned. We'll go back and then we'll continue onwards. My function. But this is loop 64, so it goes to the label. Oh my god, my brain just kicked in. Oh my, holy shit. This is actually just batch language. Bro, this is Microsoft batch language, bro. You know batch scripts? That's what this is. A BATCH script. Not a bash script. It's a batch script, bro. That's what we're doing. We're learning how to use the CMD in our fucking shit, bro. It's CMD right there. Command prompt. All right, we're gonna create another one called global loop loop. We'll just call it a loop, and then dot type. We're gonna call it a loop, comma, function, bat file, script in short. Yeah. That's what we're making. We're making our own batch file right now, bro. P2 align. Set it to 4 because that's important, I guess. I don't know what it does, but they said it was something about making sure that it's not like out of alignment with the 8-bit register. Fucking something. Some magic. Who knows? I mean, I don't know. I just work here, guys. I've just started learning assembly yesterday. So we're going to do the same add, but now we're going to test if it's equal to another register. So that means you need to set that register. So what you do to set a register is set a register or something. Something. So I guess you would do a move, right? You would do so we'll always go back to the label, and then you would do a move, maybe? The move would be like... move x1 to... So the value you put in x1 is the one that you're subtracting each time. I'm guessing you would move x1 to... or actually you would copy x1. Like, duplicate it to another register. That way... it's also there too. But I don't know. Let's just work on the actual x0 comma x0 comma x1 to say that we want to add to x0 the value of x1. Then we'll go ahead and do this. Not that. Go over to here. We're gonna do a I guess CM compare until it's equal to x. So we'll take 3 ints. Actually, we could declare this by just doing something like this. x2. Now, how does x2 get declared? x2 is going to be the third one, I guess. I suppose. Then we'll do it the same way. We'll do the return before the comparison. So that way we can get a value back from it. No. Maybe? I don't know how D does it, so I'm just going to go ahead and assume that I should just write the return here, and then it will return every time it does that. So that way I can just write line for what it equals, and then boom. And these will all be int kind of things. B.ne, and then that will be loop. And I don't know if it needs a return at the end, but I'll put one afterwards on both of them. That way, if there is any value, we'll just put it out before. That should be everything it needs, except we need to declare x2 somehow. So I guess you do ABC. So you do int A, int B, and int C. So, I'm sure this won't work because I didn't really follow exactly how they do it. Alright, we're going to do AS-O, what is it, AR, or my function, my unc, bro, I was about to put my unc, bro, my unc.o, and then my, bro, that's crazy. Func.s. If it doesn't work, we have to go and reprogram it and figure out how to make it work. Hey, I guess it worked. Oh my god, I'm so good at it. Look, I'm the assembly programmer of all time, bro. Some people would say I am the assembly programmer. Assembly Master 500. They'd call me Assembly Master 500 because I spent 200 years working with Kronos on not Kronos group, no, Kronos the god, to learn assembly. Yeah, I mean, it's gonna fuck up. So we're gonna, oh, we don't even have a call for it yet. We haven't even actually done we have to make the D program represent that shit. So now we have to call extern C a bunch of times, so. Capital C, int, loop, 64, which would loop 64 times, and then have an int A and an int B. which won't change. Unless you make them change somehow, but I don't know how you do that. Extern C int loop needs A, B, and X because we've already used C. But C is not there. So technically I could just do int A, comma, int B, comma, int C. And this is basically just like making a regular function in dlang. The only difference is that you declare it's an extern function using extern C, essentially saying external C code, but it's not C code, it's assembly. What if it was extern V? I think that'd just be an import at that point, but who knows? I wonder if it writes it as C assembly or as dlang assembly. I mean, I think the difference is pretty sparse, but still pretty interesting. Because dlang assembly is interesting. So to actually do this, we're gonna create functions for each. So this is no longer gonna be void main. This is gonna be void add. So then when I put add in here, I'll just be like, oh yeah, I'll put that in my void main. So now I'll create 3 functions. We'll do void do 64. This is cool. I like this a lot. This workflow is fun. Oh man, I love this shit. And then we'll have to figure out how to make loop 64 do something. Now, does this need internal inputs? No, it doesn't really. It doesn't really need input. So we could have the user do the same shit we do for the setting it. So to set it, you would just have int 3, and we'll call it data. Doesn't matter because it's in a separate function, in a separate scope. Well, int 2 data, and that will be the subtracted and subtractant and or added and non-added to the loop. I don't know, to increment function. Who fucking cares? Data. Then we can do our actual for. It's literally the same code as the first time. For int count semicolon, and then until count does not equal, or well, do until count equals 2 semicolon plus count and then finally we're going to do write ln to input the actual number. So write ln input int for, what is it, size? No, the size is 64. Oh, input starting point. So you could put in start value as 32, and then you only have to do it half as many times. Ooh, very useless. This is a very useless function, because if you wanted it to loop it's going to loop 64 times, in theory. If it works, it will loop 64 times, right? But you can set the start value, and if you were to set it to be, what, 32, you only do it 32 times. If you set it to 16, you're doing it 48 times. You set it to 60, you only have to do the loop 4 times. What is the point in having a fixed endpoint in a loop? There is none. Well, unless you wanted to have that. Anyway, I'm glad this allows me to program in my favorite language at least. D-lang, the best lang. So that's great. I love programming. I'm a master at programming. They call me Cobb Gates or some shit. Oh shit. With my Commodore 64 Pi. Oh shit. Input start value. So we input our start value. Then we also have to input increment. I could probably make my own an overload of sorts. Because if something goes wrong, the endpoint can be used to stop the entire program like a kill switch. Like an overload of sorts. Oh, but that's a 169 IQ level thing. Forget it. That makes sense. So that'd be useful, I guess. Yeah, so that way it doesn't keep going. Because I know when I was starting out, I would write programs and then the loop wouldn't function the way, and it'd just keep running in the terminal. And then I'd have to close it. So if you do that, that's smart. I like that. Thank you for thinking in a way I couldn't think. So write ln, we need to do a readf. And then comma, and then do our data. Literally the exact same shit we just did, but the third one will be a little bit different because it'll have to be, since we're literally making the user declare what the actual values are for these. But I think the third one will be the coolest if it works, since then you set the endpoint. So that one, loop 64 is not cool, right? But loop, whatever that one is very cool to me. Because then you can say, oh, I want this to loop 300 times. Boom. Actually, you know, maybe I'm writing Jobito code. And that's what the future is. We're going to make Jobito interpreter. Jofido, or whatever it's called. Whatever, what's his name talks about it. He wants to write Jofido. It's like Jody or some shit. He wants to write Jofido because he hates Rust and the Rustations, which I agree on the Rustation thing, but Jofido is a crazy language idea. But I feel like if you just, this would be like simplicity like that. Well, actually, you know, keep it simple, stupid. We just gotta keep writing in assembly. Well, I'm getting distracted. I need to put it in count. I'm sorry. Tab. Nice. Now we have officially completed that part of the program. We can now not do int C. Actually, do we need to do that? Yes, we need to do that. Int C equals loop 64. Something with loop 64. And then data, comma, data. And if there was another one, dat, comma. I wish I could be more descriptive of my naming conventions on these. Be like, oh yes, data from this. Oh, but that's terrible. Be like, data from assembly program. That'd be a terrible name for some variable. Be like writing 1,000 words to represent what it is, and that's shitty. Then you do write LNC. Boom. Oh, before we do anything else, I think the next step is calling C inside of a program like this. I feel like it would be a pretty cool thing to play around with. Alright, so then we're going to do void do, just do. I'm making Python. It's a rule in the IT department. Don't ever regret your first 20,000 lines of code for your project, because it will end up working one way or another. True. Some point I'll re-reference code that I wrote so long ago. Actually, it's important to learn by making mistakes. So we need to do int 3 data. Did I put colons on any of these? Let's go ahead and make sure I didn't put colons anywhere. Okay, I squinted hard enough and I didn't see no colons, so colon cancer avoided. We are continuing on the next mission. Then it's time to do int count. I love counting, yes. Count equals 3. 3, the magic number. Why is it 3 this time? Because it's not 2. Okay. It's not 2. Plus. Count. I love this so much. I am the master programmer. Write ln. Input start value, comma, increment, comma, then end point. Or, what did you say? Overload. Nice. So your own custom one. Ooh, the custom one. And, readf. We're gonna create fish on. It's gonna be like Python, but by me. And it's gonna be so powerful that it's gonna change the world. It's gonna change the world. Because it's gonna be in every single part of every aspect. It's gonna be mandated by the government. It's gonna be that good. It's gonna be memory safe. It's gonna have all the buzzwords, like unhackable. It's gonna be a restricted programming language. Right? Buzzwords. Gotta fill it with buzzwords so that way people know that it's a great language because of my buzzwords. And then we can sell it as under a wishful thinking. Amen. We could sell it as under proprietary license that we make up to undermine everything. Custom proprietary lang license. Well, that'd be fucking terrible. All work written in this language has to include this line of code that prints my name on the screen. That'd be crazy though. It'd be like comma data 2. In music there's like a license where you can be, well actually it's just like a Creative Commons license, isn't it? There's like a license for like musicians and they like means that you can like, well at least that's the one that White Bat has. White Bat Audio has that license. It's got like a license where you have to put his stuff under your video so that way then, if you use it in any work, you have to attribute it to him. Yeah, attribution, that's what it's called. That's an advanced word I've never thought of before. Attribution. Alrighty. Let's do this, bro. Alright, so now we're gonna do void main. And we're gonna do this. We're on our way towards the fish runtime. Runtime, go fish runtime environment. Add. Do 64. I like this. That's a funny name. Do 64. Do. That's good. It's not as funny as Do 64 is though. It's like DOS. Like it reminds me of DOS for some reason. MS DOS. Check for comma. Yeah, check for comma. Whoa, bro. Alright, now we need to go ahead and GDC our fun program together. So GDC call.d. We wrote those lines of code. GDC call.d. And we need to do and myfunc.o. .o and dash o and call awesome. Oh god. What the fuck? Variable name expected after type void. Do is a keyword? Oh. Son of a. Do original. Alright, let's do this. Let's try again, bro. Maybe we should call that one Utah. doesn't even describe what the name is. Call it Utah. California. Ugh. That one didn't have as many problems. We're getting closer. Closer to the goal. You know what the problem is? I know exactly what the problem is. That my lungs are full of gunk. How am I making this mistake all the time? I am stupid though when I do this shit though. Oh. Control S, Control B. Oh yeah. I like the GDC program, bro. Wait, that could be something else. I like the GDC GNU decompiler program, bro. There we go. GNU, bro. I like my GNU. My god, bro, I am the programmer. I am the turbo programmer. Alice? Call ASM, oh my god. We like, oh, input an integer. 2. 3. Input a start value. Input an increment. 12. 56. Oh, don't do that. Oh, wait. That's interesting. What if it overflows from there? What if I put it... We're gonna have to test that. Ooh, I'm loving this. I am McLovin' my fucking ASM code. I am the fucking super programmer. Yeah. I am the programmer. Close all tabs. Okay. I'm just checking if my wonderful shit is working or not. Oh, that's on the other side. Alright, well. Here we go. Input another number. 2. Input a value, increment, and then overload. Wait, it didn't return any values. Fascinating. Very interesting, Mr. Freeman. So it should return after the ad, but it doesn't do that. And I don't know why. Maybe because of how it works, it needs to reset the register. But I'm surprised we've gotten it this far, to where I've now got a D program that's didn't take long to make, and able to have 3 of these different assembly functions. We're starting to work on loops, so that'll be good for next time. So we're going to do input a star value 0, input an increment 1, an overload 2000. Oh, it did return 1. Very interesting. X2. But how does D decide what needs to get a new, what needs to get that assigned? So actually, what we need to do is test, yeah, like I'm surprised it worked on first try, but it's unexpected behavior. Like what we need to test is the actual register value for data 2 on both of those ones. Because I figure, here's what's going on, is that, well, on the first one it doesn't return anything, so that's a problem inside of the actual assembly code itself. So if it's a problem with the assembly code, it's not returning anything. Not returning any value at all. So maybe it needs to be done manually? If it's not that, it's not 64. Damn, bro, I got the colon from HBM mod now. Okay. We've made progress, but it's not the progress that we needed to make. Oh, shit. Oh. Okay, I found ASCII Aquarium. I'm trying to grab my tabs from the other side. I'm just grabbing one tab at a time. Bro, this is so bad. Oh, I've grabbed my YouTube tab. Splendioso. Oh, I finally grabbed the rest of the window. Oops. This is amazing. This is actually the most brilliant way of doing shit. Oh. Interesting. Very good. This is so good. Okay, so we've gotten that to work. Does it need a return? So it has right lines, so that works as expected. Those are voids. And then we've declared our external functions as ints. And that's how they should be declared. Then can we somehow return the value of... So with that... And then check if the value at x2... Oh. Define a function entry point. The indented code is part of the function. Okay, so run the C main function. We got this here. When we call our assembly code, we pass two input values in registers x0 contains the value 4 and x1 contains the value of 7. So x3, I don't know, it's x2. Yeah, so x2 should take the output value in that third equation, which is the problem that I'm going to try to solve, because it did return a value at the end, right after the add, but then it was like, everybody I see, even me included, is clearing throats. Like it's the worst weather ever. Yeah. No, it's just so unexpected. Like, I don't know. My throat isn't sore, it's just started like 5 minutes ago. I don't know. It's coal miner's lung. Too much dust. Or something. Scrolling up. So, how do you specify which values you assign? Like, if you assign a... How do you do that? So... So they put in... let's go through a line by line, because they have a line by line section. Let's do it again. So... Run the cmain function. When we call our assembly code, we pass two values in registers x0 contains the value 4 and x1 contains the value 7. My function, define the function entry point. Intended code is part of the function. Oh, okay, so that defines that. Decrease the value x in x1 by 1, making it 6, and then overwrite the original value in x1 with the new value. Then they do, and they make it x2. Oh, okay. Difference between x0 and x1. Store the difference in x2. Check the value in x2 is 0. .bne.my function, check the value if the value in x2 is 0. I see. Oh. So they're decreasing that one. So they decrease their x1 the entire time by 1, so they decrements down. And then decrements down. And then they do a sub 2, and then they assign x, or they subtract x1 from x0, and they assign that to x2. And if, what is x0? X0 is, I don't know. So they have they're showing how to investigate it in the ARM developer, how to use GDB to do it. Okay, how to investigate those values. Probably good to use GDB. I feel like I got a lot more to learn. I feel like I've learned enough for today. Alright. Yeah. I feel like this is a good point to wrap up, and well, the programming part. But I do have some other stuff I think we'll do today. So, bear with me while I Control S on all of these. Start getting everything ready. Alright, tmux kill-server. Now, what we're gonna do is we're gonna try to get Pacman dash s. Was it yay? No, it's not found. Alright, well, we're gonna try to figure out how to do this and get the Pacman-S shit to work. Alrighty, Pacman-S. Oh. Got my keyboards confused. Make sure you have the base, the necessary tools. Need base devel. Oh, okay. Sudo. We don't even need to do that. We just gotta do Pacman dash s dash needed base dash devel and get. Sure. Holy shit-a-roni. What the fuck? Damn. I like this. This is spectaculoso. Gonna do the arc thing. And then we're gonna try to get that aquarium thing in here. So the next step, it says this will be a different journey of its own. Yeah. We're gonna do git clone. Okay. Here's what I'm gonna do. I'm gonna cd dot a couple times. There we go. We're gonna go to here. Technically, you can do cd comma and then dot. Hold on, let's try that. No, let's try that later. We'll cd all the way down to the bottom and then dot. Like you can do a comma. Or actually, let me demonstrate. ls comma. Oh, never mind. Well, actually, ls comma. No. ls slash. Dot. Oh, wait, hold on. Damn, that's pretty cool. So you could technically just do ls slash, and then if I wanted to, I think you can do dot, and then, no, okay, never mind. Wait a second, no. I know how to do it. I think I know how to do it. I can do ls slash, dot slash, dot. Here we go. Now I'll be cooking next time I do my CD. Goes all the way to, oh, it just runs it a couple times. Once you get the aquarium working, you will not know ID. It will be able to run i3WM or not. You will know ID. It will be able to run i3WM or not. I'm confused what you mean. Anyway, we need to go ahead and get clone the actual thing. Git clone https //aur.arc linux.org /yay.git. Perfect. Use make, okay. Make pkg -si. Son of a... How do I run it as a user then? Maybe I could do... How do I... Oh, what about a Switch user? No, like SU, right? Damn. Alright, user add. We'll do that. Then we'll do SU. Oh! Oh, I am no longer the root user, guys. I've learned how to do it on my own. Indeed, I have. I've made myself into, myself again. Jesse, we need to cook 50 kilograms of meth. Perfect. This is a brilliant moment. Right here we have achieved a great thing. Oh, but now I can't do the fucking make package dash SI. I have achieved something I never thought I would be able to. SI. Huh? LS. CD yay. Slash. Need to use the yay folder first. I'm confused. Oh. To compile the package from source. It does not compile the package at all. I'm confused. What does this mean? What about LS? Let's try LS here. Oh. CD PK. Oh, let's try LS PKG build. Son of a. Oh, it's capital? Why would you capitalize such a thing? Okay, maybe C. Oh. You know why I didn't do it? Because I didn't put a slash afterwards. CD PKG build. Okay. Case sensitive? Oh, wait. Is it capital? Oh, yeah, that's a good question. No, it's lowercase. So we CD'd in there. It's weird. Very interesting. Damn. We need to well, I don't think this would be one where you need to sudo it. Maybe you're right. Oops, already fucked it up. Try that. How did I fuck that up? Wait, I don't have a password. Oh, wait a second. No password. What? What the hell? Yeah. How do I make a password then? Is it MK or PASWD? There we go. Authentication failure. Do it as root. We can't do that. The other thing is root. That won't work unless you want to change password as root. SU root. Okay, let's try. Okay, new password. Try that. There we go. And then try that. Yes. Right. That just changed the root password. Am I dumb? Alright, then we'll try the sudo. Well, let's try it. Oh, can no longer sudo the package. What was it? PKG make or like make PKG? No, fucking make PKG dash SI. Please work this time. Oh, look, there is no password. Because I am dumb. But I don't know what I'm doing. That did not work. Yeah. I really haven't used many user commands before. Let me see what to do. I'll see what to do. Okay, let's see how that works. Password, username, and then it should change it. You must have root access or using sudo. Unlike changing your own password, the system will not ask for existing password of the user to ensure accuracy. Okay. So that didn't work. Wait a second. Oh. What if we try, we are still in the yay directory. Wait. Why are we alarm? That's weird. Add alarm. I like how it says at alarm. That's our host name is alarm then. Or something? Something like that. That's weird. I don't know. Damn. Make package at -si, and then so we can't do that. It's not capital. It's not capital SI. Then you do cd dot to go up. And then rm rf yay. Confused. Okay, that one didn't. That's not it. I mean, maybe it's that it's. Because I tried root. Okay, that's not working. And then, just double check that one. That I didn't put that in wrong. Okay. SU. Okay. And then redo it again with a simpler password. Alright, yeah, that's a good idea. Successfully. Okay, maybe it didn't say that the first time, did it? I don't think it did. I think it said probably did not succeed or something. Let's try. Yeah, let's try the SU Heisenberg and then try the make package again. Okay. Failed to create directory. Okay, then try sudo. Damn. I think there's a way to do password like list, but I don't want to do that. Yeah, okay. Let's see, SU root. Wait, isn't it like user mod or some well, that's to add them to a group, like user mod -ag to add to a group. Oh, well, I guess we won't be installing Yay. But isn't there another one where I could get that off of? The disrespect from every language possible. I don't know. Root password works. Run make package as SU. Well, we've tried that. Unless that's what we did is ran it as SU. Or what do you mean? So you mean like SU make PKG -SI? Oh, SU. Oh. Huh? Wait. I wonder if this is the issue. That'd be funny. We should always start with the simplest question of what could the issue be. Okay, that's not a thing. What about Pac-Man? Okay. I like how it doesn't even ask me for a password to switch from root to the... Right. Actually got an idea. Roto. Root. Oh, actually... Can a user... Maybe I need to actually add the user to a pseudo group. Hold on. Because maybe I don't have privileges to use sudo. Arc? Arc? Yeah, arc. Sudo package. We have a sudo package, right? Hold on. Oh, this is a great question now. Sudo. Okay. We need to make myself a super user doer. su root. And then do sudo dash u dash dash u. Oh, sudo dash u user. Oh, I just switched that. Sudo dash u right? And then command? Maybe? Is this, like, weird? Whoa. Hold on. It didn't say anything about us not being able to do it as root. So now root can force that, but at the same time, group list or groups list. Actually, just groups, right? Root ls dash id or ld. Now that is not how it technically works. Okay, I don't know how it works technically, but I mean something weird was going on there. ld. Ah, I see the kernel, 3 root, or root, and 4 something with L. Yeah, I think we need to pacman dash s u and then try to do that on sudo. Yeah, we can do that. We could do this. Yes. Hit the Y button for yes. It did something. Alright, sudo. Let's try. Maybe it has to do with permissions directory wise. I don't know how to mess with that. Or maybe we could do. I don't know. I don't know. Oh god. Yeah, this is time for when a graphical interface would come in handy. Oh shit. I mean, this is just a side project anyway. It doesn't really matter that much. think, let's try it one more time. And then sudo make pkg. Oh! We have it. Okay. SU. I don't know what that did, but the fact that we got it running on a Pi is sick. Yeah. Pi 5, though, is crazy. Alright, we're gonna go ahead and switch. Do that. Alright, so I'm back to here. We're gonna do sudo -u. Right? Wrong. No, wait, that's to, or we could do group add. Or no, that would be adding a group. User... What was it? User mod? Plus AG. Right? Or actually, let's try groups again. Root. Okay, so we need to do group add. And then we need to add a sudoers, or actually, sudoers file. Where's the sudoers file? That's a good question. Wait. Okay, so maybe it's sudo -u. Oh, add user. Okay. Sudo. That's, or maybe user add. Let's try that. Oh. Did it do something? User add. Ooh, okay, I don't know. Oh wait, you can do -p to add a password. That might be useful. What if it's not added to the wheel yet? There is no wheel if I look at groups. I don't see wheel in there. There should be wheel. Maybe groups -a. Man, I love Linux, bro. I sure do love it sometimes, and then shit works perfectly. Man, at this point, I might as well just fast fetch. Boom. I like that a lot. Need to create a prompt that runs it constantly. I just love looking at the fact that it's on a Pi. Uptime 2 hours and 40 minutes. Each user base is run on a wheel, like a gear of its own that has it decided whether it really uses the commands or not. May not be implemented in being implemented isn't the issue. Okay. So then, how do we fix this? I don't know if I should ask how we should fix this, but that is a good question to ask. Packages 220 from Pac-Man. Some people show me their 76,000 packages, and I look at them and call them a madman. VGA terminal font. Nice. Nice. LSPCI. I like my LSPCI, bro. My integrated graphics cards. Bloat. 70,000 packages, man. That's perfect. What was the other AUR that was available? Or actually, there was another AUR that you could use. Paru. Alright, so let's try Pacman-S Paru. Ha ha, son of a. Can clone the packages, Git repository, inspects. Oh, what about linutils, bro? Linutils would be so fucking useful for this shit. We have Paru. Chaotic ore. Alright, let's try chaotic. Chaotic. Is it AUR? No. Maybe it's just chaotic. No. We get clone. Yeah, but that's what we did with Yay, and it doesn't want to do anything. Yeah, actually, usually the answer to these problems is just to shut everything down and turn it back on again. Let's go ahead and give it a shot. Let's try that. I bet something's wrong to where I just need to shut it down and it will work. Flashbang! Oh god, it's brought up to my fucking arc. Oh shit, oh, where's my arc button? Arc button, oh. I cannot see a thing. Oh, you mean AUR helper? No, I meant Peru, but I thought another AUR repo. AUR helper, so we should try that. Oops. There we go. Yay and Peru is AUR helper. So yeah. So we're gonna do users. Root is the only user. Groups. So I thought there was more users than that. So what if we had AUR isn't just one repo. We have a community made ones too. They're called helpers. They take it straight from AUR and auto-compile them in front of you. I'm actually curious how I can change the fan settings. That might be a difficult thing to do, but I think it's possible. Because this thing is hot right now. It's like melting. Melting hot, bro. It's on fire. We must change the fan settings. Oh, so we need to go through device tree overlays. This is a Pi 5 though. Let's see how that works. Fan control. CD ... ls. There's boot. CD boot. ls. Fan control is what we're looking for apparently. Apparently it's called fan control. So we're gonna look for that. Is it like that one closest with stuff? You can either take it from there directly, or you ask a helper to go fetch it for you. And then build it all and do all that shit for you. It's pretty good. Config.txt. Should be a config.txt. Oh. I don't see config.txt. Did anybody else? Maybe it's hidden. Okay, you know what? Let's oh, I see config.txt. Alright, I want to change the fan settings. It's slow as hell. There is no fan settings. What? You can customize the fan behavior by adding specific parameters to the boot settings. Okay. This is very cool. So I have this and it says allow run as fast as firmware / board allows. Uncomment this to enable infrared communication. I don't know if I have to uncomment that. I guess it's just on by default. I guess some of these are on by default. Okay. VC4 V3D driver? What is this? Don't have the firmware create an initial video setting it up in command line.txt. Boot overlays.readme. Optional hardware interfaces. DT param. SPI. Oh! These are for I2C, I2S, SPI. That's all communication protocols using the actual shit. I know what that is. Greetings, human flesh. What's up? Welcome back, some guy. We're gonna do the fan settings now. Oh, and by the way, CM4 and CM5 are Compute 4 module and Compute 5 module. Custom fan settings. Hashtag. Fan temp. And fan temp and hist, and then fan temp and speed. I'm not putting all the underscores in there. It's too much work for me. I'm lazy. Let's go ahead and continue. Alright, so now we can do fan underscore temp 0. And 50,000 equals 50,000 Celsius. So I would say probably at 40 Celsius. We want that to kick in because it's pretty hot right now and I know for a fact it's hot. Could potentially be super hot. And we'll have it kick in there. And that last is a percent, right? Oh. For that cooling level. Underscore hist equals 5,000. What is 5,000? Hysteresis in millicelsius to prevent rapid cycling? I don't know, but we're gonna put 4,000. No, put 5,000. They all do that shit. There is no semicolons on these. These are just normal configs. Fan underscore temp. Don't see anything about fan control being in the config in Rasp stocks. Yeah, but this is the AR, or this is, I don't know if it's gonna be there because this is Arc. This is Arc Linux on Pi 5. Pi 5 is also pretty new too. It's like got all the, well, it doesn't have all the fancy AI stuff, but it's for AI stuff. Is what a lot of people think. So 75. I think I'll go with their settings because it looks pretty good to me. 75, and then I can do, who knows if this will work, but hopefully it does. Equals 50,000. See if I can knock these out faster. 5,000. Underscore temp 1 underscore, then it should be like 125. Is what it says. Okay. Who knows what this will do? Wait, I'm not putting, I didn't put equals. Oops, I'm very dumb. Skip that part. Hist equals and speed equals. Actually, it'd be easier if we just write out all those and then figure it out later, I think. So let's just write out a bunch of fan, because we only need like, what, a few more? And then go back up and do our underscore temps. Yeah, well, I only need like 3 different temps since they start at 0. This is very easy. Alright, then temp 2. Ah, what the fuck? Oh shit. That is bad. Temp 2. Temp 2. Temp 3. Temp 3. And then temp 3 underscore. I should have done the underscores before. Then I can just do equals on these. Doing this way faster. I feel like this is way faster to me. It feels faster to me. That's all that matters. Before it was just pain. Got it. Everything looks good. And then of course we can do the 5,000s on these. Then Okay, then it's up to us to decide the numbers from here. 60,000, and it goes up to, apparently it says 250,000? Or no, not 250,000. Bro, that'd be like 250 degrees Celsius. That's not how high it goes. Oh, if it gets 200, if it's fucking fiery, then turn on the fans now. Bro, that'd be fucking, oh, fan the flames, bro, fan them away. If it's on fire, turn on the fans. Alright, that should be what we want. I think. So, and then, of course, send myself to my home. My root home directory. I am root. Now, let's see. Oh, 0 to 255 for the PWM level, by the way, which is the spin speed, I guess, of the fan? I don't actually know. I'm not actually sure. This is alternative GPIO fan overlay. There's one for GPIO fans. Interesting. The active cooler is controlled by the Raspberry Pi. Firmware, which uses the default cooling curve thresholds at 50, 60, and 60. Customize these parameters to allow. Alright, so then I probably have to reload it. I guess maybe reload. I feel like there's a VC Gen CMD apparently. Try that. VC Gen? VC Gen. Alright, let's go ahead and reboot it. I think it will work when we reboot. This is Arc. This is not normal Pi. The normal Pi stuff won't work necessarily, but at the same time, maybe some. Oh, that sounds about right. Sounds like it's kicking in. Well, it was just during the boot. The boot does it weird. Damn. This is terrible, bro. Gotta make a whole new password for this thing. The leak is amazing. Oh, shit. Alright, guys, it's time for me to clear this and make a new password, I guess. Oh. Bro, I fucking... Man, if only it defaulted to root. That wouldn't have happened, bro. It wouldn't have happened. The password leak of all time. It's okay. Let's see. There we go. Okay, now we gotta do cd ... Then Actually, no, we don't have to do anything else. Nano boot slash config.conf or some shit. What was it? Config.txt. Apparently, none of these actually kicked in. Config underscore text.html. I don't think that's the case. Or what? Is that where we're at? Or that? Nah, this is the one we need, apparently. I knew the electricity department was up to no good, so I built my own magnetic motor, and at least the Wi-Fi will work without electricity. Did I miss anything? No. Not really. It just doesn't work. The attempt to change the temperature, fan settings on this doesn't work. Pi begins to reduce performance throttle at 80 Celsius to manage high heat. At 85 Celsius, it aggressively throttles to prevent damage. This is normal protective function. Safe operating range. While the Pi can safely reach 85 Celsius, sustained high temperatures can shorten component lifespan. For optimal longevity. Nice, but how do I change it? How to change the things? Because I'm pretty sure this is wrong. This is not correct. Aha! DT param lines. What? DT param? What the fuck is this shit? It's made up some new shit now. Slash system slash class thermal? Okay. I'll do that. Slash class thermal. Ooh. Ooh. That's good. This is good. Fan? That'd be like the firmware, right? For the fan? Or no? No, actually, that wouldn't be. Alright, let's see. You know, I don't want to look through all that. Let's go ahead and do, slash thermal. Cooling device? Cooling device 0, I guess. Fan temp 0? Well, what is in, is that that's a folder, not a file. Or it's a file without an extension? Let's see what we can do with this. Interesting. Very interesting. So we should just use that in the boot config, or no? No to the boot config, or current state? Let's try slash cur underscore state. Nothing. Oh wait, dash A. There ain't nothing in there. Okay. Interesting. Power subsystem. Try subsystem. Try that out. Thermal zone. Cooling device 0. Try thermal zone. Thermal zone 0. Whoa. Overclocked my CPU to 399 megahertz and it still works? Wow, what does that do? Trip point for type. So did it like go faster? How'd you get it, wait, to 399 megahertz? That's not gigahertz, right? Like, you know, you didn't do gigahertz? So why not gigahertz? Why not go for the big G, 399 gigahertz, bro? I don't really know what to do to edit the power. Maybe it's got to be a fan device, but hold on a second. See, it'd be cool to like overclock a multiple CPUs on a server, and then see what happens then. Overclock the RAM too, bro. Overclock the entire thing. In the Pi 3.4, you can create a bash script that monitors the temperature and adjusts the speed via the sysfs interface. Oh god. Or I could just do this all by hand, I guess. Huh, who knows? It's not really that worthwhile, is it? I mean, it is slow, it is very hot. But, what's that gonna do, stop me from using it? Hell no. It would be nice if there was just a fan controller that was easier. Create a system D service. I don't want to do that. Expensive heater than a computer. Cooling device and cat its contents. Hold on. Well, I haven't gone anywhere. I'm gonna just look on the Arc Wiki. Actually, no. Fan control is a part of LM sensors. What if we just did like some Pac-Man something to control the speed of the fans? Oh, here we go. Arc ARM. They have a section there. PWM fan control. This is like kernel level stuff too. This is stuff I don't really want to do. Well, I think I'm done with this. Thank you all for watching. I'll see you all in the next one. We did some programming earlier. It was pretty good, so I'm happy with that. Maybe next time I'll have some more shit for you all, but until then,